So hi everyone, I welcome you all to this series of thermodynamics lectures that is going on SATHEE. So today I will be going to discuss few questions related to what we have done till now. And before going to the questions, I am just recalling the different kind of thermodynamic process that are there. So different kind of thermodynamic processes that are there. So we are having isobaric process, which means to say that pressure is constant. Then we have isochoric process where volume is constant. Then we have isothermal process where temperature is constant. Then we have adiabatic process where heat is. So almost all the processes I have discussed with you already. So let's look at some numericals. Maybe we will use this information there. So in an thermal process, 200 joule of heat is given to an ideal gas. Find out the work done by the gas and internal energy and the change in internal energy. Okay, so we are having isothermal process. Isothermal process, we know that as this temperature is constant. So in isothermal process, delta T is 0 because temperature is constant, and so we have Q, that is 200 joule, that is given to the system, that is taken to be positive. Okay, so from the first law of thermodynamics, we have delta U is Q minus W. So we know Q, we need to find W, we don't know delta U. So for the isothermal process or for any process, delta U is defined to be N CV delta T. Because it's isothermal process, we have already defined delta T to be 0. So that means that delta U is 0, and so whatever the heat is given to the system is going to be converted into the work, and that's why. So this is 0, this is 200 minus W, so W is 200 joule. So which if you wanted to see like with how the process is going, so if we are having a piston, so isothermal process means the temperature is always constant. So whatever the heat is given to the system, so if you are giving heat, the work is done by the system, so gas gets expanded. So whatever the energy you give to these gas molecules, they will use all that internal energy, all that heat to increase the volume or to get expanded and then to do some work, and so the net internal energy is 0. So that is the process. I hope it is clear. Then we have another question. So the question is this: so we have this process shown in this diagram. That is A to B to C. So this is PV diagram. This is JEE 2014 question, I think. So no points are given, only what is given is the temperature at different points. So at A the temperature is given 400 Kelvin, at C the temperature is given 600 Kelvin, at B the temperature is given to be 800 Kelvin. Okay, so the 1 mole, so the question is, one mole of an ideal gas undergoes a process depicted through PV diagram as shown in figure. Find out or choose the correct option. Choose the correct option. Delta U A B C A is 250 R. CA is taken to be 750 R. AB is given to be 350 R. Given to be minus 500 R. So we need to find out, we have to check with which option is correct. So if I have to find out delta U, because internal energy is path independent, so that means that delta U is A B C A is nothing but U at A minus U at A. So U at A minus U at A, so that is for sure 0. I can use blue pen for solution. So delta U A B C A is nothing but UA minus UA, that is 0. Delta U CA is, so from C to A, what you will see, we need to find, so we need to apply first law of thermodynamics to get delta U from C to A, or can we get this from C to A just by using our usual formula NCV dt. We know delta T because temperature is given at all the points. So CV is so because it's the diameter. So I forgot. So it is, the correct question is this. So for diatomic gas we know. So diatomic gas we know CV is 5 by 2 R, and everything is in terms of R is given. So moles are 1, 5 by 2 R, and delta T is taken to be 400 minus 600 from C to A. So this minus this, that is minus 200. So it is coming out to be minus 500 R. So this option is not correct. This option is also not correct. Let's look at delta U AB. So delta U AB is and CV dt again. We know now, when we know temperature, this curve, we don't know anything. We wanted to find out the change in internal energy, and we have temperature, and we know CV. So that's fine. I don't need to look at what is going to happening in this process. We just have to put in the formula. So 1 into 5 by 2 R, and delta T is from A to B. So B minus A. So 800 minus 400, that is 400. So that is because internal energy is part dependent. It doesn't matter how you are going, where you are going, doesn't matter. The only thing that matters is what is the internal energy at point A and what is the internal energy at point B, and you have to find the difference from that. How you are going from A to B doesn't matter because it is part independent. So that is 1000 R. So this option is also incorrect. So if all of 3 options are incorrect, then you don't need to find this. This is correct, but to check it, let's find. So delta U BC is 5 by 2, 1 into 5 by 2. I am directly writing, and into CV delta T is 800 to 600. So that is minus 200. So that is minus 500. So the correct option is this. So very simple question. You don't need to get panic by looking at this curve. This curve has nothing to do with internal energy. What you have to just look at it, that what is the temperature at A, what is the temperature at B, and what is the temperature at C, and just forgot about this curve and just write like the temperature at A is T is equals to 800 Kelvin, temperature at B is T is equals to temperature at A is temperature at A is 400 Kelvin, temperature at B is 800 Kelvin. Temperature at C is 600 Kelvin. So just you forgot about this curve. If I am saying going A to B, so final 800 minus 400, I am going from B to C, 600 minus 800. I am going from C to A, 600 minus 400. Just look at this and find out the internal energy, because J is the exam J is not really all the questions are very tough, but it is the exam of your how you are going to think and how you are going to tackle the problem you are given. And so if you get panic with by looking at the curve or and think, oh, what can I do with this curve, so then you will get panic and you will do wrong things with the question and you will get wrong answer eventually. So instead of get panic, just cool down yourself, calm yourself, and just look see that, oh, I just need to find out the temperatures. I have temperatures at different points and I only need that to get the internal energy, because internal energy, as soon as someone going to ask you the internal energy, that the thing that should strike in your mind is that I do not worry, I should not be worrying about the process. What I should be worrying about is the temperature given to the at different points. If temperature is given to me at different point, then I will eventually get the correct internal energy for any processes growing from one initial state to another final state. So that is this about internal energy. Let's look at another question. So the question is this. So we are having a PV diagram given again. So the PV diagram is given and the process is something like this. This is final. Process is going from this A. What all I have is UI is 100 joule, UB is 200 joule, QIAF is 500 joule, WAF is 200 joule, WIB is 50 joule, and WBF is 100 joule. All this data is given. I need to choose the correct option out of the following. So the correct option for Q for so I need what is asking for QBF by QIB. So I need to find out the ratio of QBF by QIB, and that is for that I have to choose the correct option. So the options are 1, 2, 3, 4. Okay. So as I already told you, we have everything there. We really need to think about, because all the works are given in all the process. So now because work is already given, so we don't need to worry that how the process is going, because work is the only thing that is dependent upon the path, and work is given for all the paths. So if I have to find so So I need to find QBF divided by QIB. So I need UBF and UIB for sure, because I know WIB and WBF. So from by applying first law of thermodynamics, I will get QBF and QIB. So basically what I don't have is what is the UBF and what is UIB. So let's process. So QBF, let's first write first law of thermodynamics. So so delta U BF is nothing but Q BF minus W BF. Delta U IB is Q IB minus W IB. I need to find the ratio of this. So QBF is delta UBF plus WBF. QIB is delta U IB plus W IB. So QBF by QIB is delta UBF plus WBF divided by delta UIB plus WIB. Let's put all the values what we are having. So I don't have delta UBF plus WBF I have, that is 100, divided by delta UIB I don't have, again WIB is 50. So I need to find delta UBF. So as I told you, delta UBF is nothing but UF minus UB, and delta UIB is nothing but UB minus UI. So I have UI, I have UB, I need to find UF. So for finding UF, can I say that in going from so delta U I have IB, I have BF, so that is delta U from and delta QIAF. So delta UIAF, in terms of IAF I have to write. So that is QIAF minus WIAF. So this is WUF minus UI. UIAF is 500 minus IAF. So in going from IAF, it is nothing but W so we have WIA plus WEF. Okay, so 500 minus, so IA, because so now this curve is important because V is constant from in going from I to A. So WIA is 0. So WAF is given already, that is 200. So UF minus UI is coming out to be 300, and from that I know UI, that is 100. So by substituting UI, so UF is equals to 300 plus UI, so that is 300 plus 100, so that is 400 joule. So now I know UF. So I have UF, UB and UI. So UF minus UB, UF 400 minus 200 is equals to 200. UB minus UI, that is 100. So UBF is 300 divided by IB is 100, 150. So the ratio is 2. So correct option is this. So I hope this question is clear and it has all complete set of concepts. Many concepts were there. So JEE also used to ask this kind of questions where you have to apply different kind of concepts. Bit lengthy, but if you are doing practice, if you did practice a lot, then you will eventually solve this question quickly. So thank you for this.